Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter chemical bonding and molecular structure. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Also in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comment section, so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that which of the following is diamagnetic. So here we have to write the molecular electronic configuration of these species, which is according to the molecular orbital theory. So according to the molecular orbital theory, the molecular electronic configuration for H2 plus. So H2 plus will have one electron only. So its electronic configuration will be sigma 1s1, sigma 1s1. And for He2 plus, so He helium 2, it will have 4 electrons, but it is 82 plus, so it will have 3 electrons. So here it has sigma 1s2, sigma star 1s1. So we, we know that if there is any half-filled molecular orbital, then the molecule will be paramagnetic. The molecule will be paramagnetic if there is half-filled, if we have half-filled molecular orbitals. And if all the molecular orbitals are fully filled, there is no half-filled molecular orbital, then it will be diamagnetic. So the molecule will be diamagnetic if we have one or more half-filled. No, if we have no half-filled molecular orbitals, or you can say all molecular orbitals are fully filled. If all molecular orbitals are fully filled, then we have diamagnetic species. Then O2 will have 8 to the 16 electrons. And as we know, it will start from sigma 1s2 and it will end at pi star 2p. Okay, so let's write it. That will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, then sigma 2pz2, sigma 2pz2, then pi 2px2 equals to pi 2py2, and then pi star 2px1 equals to pi star 2p y1. So it will have 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So here we have two half-filled molecular orbitals. So it means oxygen molecule is also paramagnetic. Is also paramagnetic. Then N2 will have 14 electrons. So if we write the molecular electronic configuration of N2, that will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, and then pi 2px2 equals to pi 2py2. So here we see all the molecular orbitals are fully filled. So it means N2 is the one which is a diamagnetic species. So hence option D is the correct answer. Then here it is told the number of antibonding electrons present in O2 minus molecular ion is? The number of antibonding electrons present in O2 minus molecular ion is? So O2 minus molecular ion, it will have 17 electrons. It will have 17 electrons. So if we write the molecular electronic configuration of this, then it will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, and sigma 2pz2, then pi 2px2 equals to pi 2py2, then pi star 2px2 equals to pi star 2py1. So the number of antibonding electrons, the number of antibonding electrons, that will be equal to, here we have 2, here we have again 2, we have sigma star 1s2, sigma star 2s2, and here we have pi star 2px2 and pi star 2py1. So 6 plus 1, 7. O2 minus molecular ion. So it means the number of antibonding electrons is 7. So 7 is not there in the options. So here none of the options are correct. None of the options are correct. Then here it is told that hybridized states of carbon in graphite and diamond are respectively. So in graphite, we have each carbon atom is covalently linked with 3 other carbon atoms in the same plane. So each layer is separated. Each means here consecutive layers are being separated by weak bonds in case of graphite. Here, these weak bonds are uh, some weak van der Waals forces. So in each layer, every carbon atom is linked with 3 other carbon atoms. So it is sp2 hybridized. Every carbon atom is sp2 hybridized in case of graphite, and in case of diamond, we have every carbon atom is linked with 4 other carbon atoms in so one tetrahedral network is formed. A tetrahedral network is formed here, where every carbon atom is linked with 4 other carbon atoms. Here one tetrahedral network is formed. So in diamond, every carbon atom is sp3 hybridized. sp3 hybridized. So it means hybridized states of graphite is sp2, and for uh, diamond it is sp3. So option D is the correct answer. So sp2 and sp3. Then here it is told a pair of the pair of compounds having identical shapes for their molecules is. The pair of compounds having identical shapes for their molecules is. So in case of CH4, we have tetrahedral structure. We have tetrahedral shape in case of CH4, and then in case of SF4, we have four four bonds with fluorine, and then one lone pair is also there on sulfur. So the shape will not be seen here. It will be like pyramidal. Square pyramidal structure will be formed, or we can say one triangular pyramidal. So here one pyramidal structure will be formed here, which is not tetrahedral shape. And in case of BCl2, so here we have linear shape, and in case of ClF3, we have 1, 2, 1, 2, 3, 4, 5, 6, and 7. Okay. So here we have 2 lone pairs and 3 bond pairs. So here it means one square planar shape will be formed. Square planar. It is not square planar, sorry. Here also one. Actually, it will form something called as T shape. T shape structure will be formed. And in XCF2, you have 1, 2, 2, 3, 4, 5, 6, 7, 8. So here we have 3 lone pairs and 2 bond pairs. So here also we have got linear shape. And in ZnCl2 also, we have linear shape. And in case of SO2, 1, 2, 3, 4. Okay. So here SO2 has got one lone pair and 2 bonds are there. So it is kind of V shape or bent shape. V shape or bent shape is formed in case of SO2, and in case of CO2, we know that a linear shape is formed. So in case of option C only, XeF2 also has got linear shape, and zinc chloride also has got the same linear shape. So option C is the correct answer. Since why it has been asked that the pair of compounds having identical shapes for their molecules. So which is happening only in case of option C. Then it is told that using MOT, compare O2 plus and O2 minus species and choose the incorrect option. So in case of O2 plus, or O2 plus, it will have 15 electrons. So it will start from sigma 1s2, it will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. So we are writing the molecular electronic configuration for O2 plus and for O2 minus species. For sigma, so sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, then sigma 2pz2, then pi 2px2 equals to pi 2py1, no, pi 2py2, and then pi star 2px1 equals to pi star 2py0. So here, so we don't have to write this. Okay. So we only write till pi star 2px1. And then the molecular electronic configuration for O2 minus species is it has got 17 electrons. So its molecular electronic configuration will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, then sigma 2pz2, pi 2px2 equal to pi 2py2, pi star 2px2 equals to pi star 2py1. So here, as we can see, so here it is. Okay. So now the bond order for O2 plus, that will be equal to half of. Now these will get cancelled. These parts will get cancelled. Then it will be half of the number of bonding electrons, which is 6 minus 1, that is 5 by 2, that is 2.5. And then the bond order for O2 minus species, that will be half of the number of bonding electrons, which is 1, 2, 3, 0, 6 minus 3. So that is equal to minus the number of antibonding electrons, which is 3. So that is 3 by 2, which is 1.5. So it means that O2 plus has got higher bond order than O2 minus. So C is the correct statement, but here it is asked to choose the incorrect statement. Now, and both are paramagnetic since both have one unpaired electron each. Both have one unpaired electron each. Paired electron each. So both are paramagnetic. So both are paramagnetic species. Paramagnetic species. So it means option D is the wrong statement, and so D is the correct answer. Since why it is told O2 plus is diamagnetic while O2 minus is paramagnetic, which is a wrong statement. Since both are, since option B is correct, that both O2 plus and O2 minus are paramagnetic. Then here it is told HCl gas is covalent and NaCl is an ionic compound. This is because sodium is highly electropositive. No, hydrogen is a non-metal. HCl is a gas. Okay. So the rule is that if the difference if the difference in the electronegativity is less than 2.1, then the compound is covalent. It means suppose a compound AXBY has been formed. So then this compound will be stable if the difference in the electronegativities of the elements A and B is less than 2.1, then this compound AXBY will be covalent. Else if the difference in the electronegativity is more than or equal to 2.1, or simply I can write more than 2.1, then the compound is an ionic compound. Then the compound is ionic. And we also know that some all ionic compound has got some partial covalent character. character, and some and all covalent and most of the covalent compounds have got a partial ionic character also. And this happens due to the difference in their electronegativities. Now HCl is covalent since why? The difference in the electronegativity of hydrogen and the electronegativity of chlorine, that is less than 2.1. So it is a covalent compound. But for NaCl, the difference in the electronegativity of sodium and chlorine is more than 2.1. So it is an ionic compound. So option D is the correct answer. Then here it is told main axis of diatomic molecule is Z. The orbitals px and py overlap to form. So as we know that px, since we know the main axis of a diatomic molecule, so this z axis we know it is also called as the internuclear axis. Internuclear axis. So along x-axis and along y-axis, the pi bonds are formed. So pi bonds are formed along the x-axis and the y-axis if the two orbitals will overlap. If the orbitals will overlap along x and y axis, then we will have sidewise overlapping. And we will have sidewise overlapping. And then, and in that case, pi bonds will be formed. And in case of sigma bonds, the overlap happens along the internuclear axis or the z axis. The overlap happens along the z axis or the internuclear axis. Internuclear axis. So here a sigma bond is formed. And in case of px and py cannot overlap, and if and with px and py there will be zero overlap. There will be zero overlap. It means they will not overlap, since why they are px is oriented along the x-axis and py is oriented along the y-axis. So there will be no overlapping. Zero overlap or no overlap means no bond is formed. It means neither sigma bond nor pi bond will be formed here. So hence no molecular or orbital will be formed. In case of when sigma bond is formed, here we have two molecular orbitals are formed. Sigma bonding molecular orbital, sigma bonding molecular orbital, and sigma antibonding molecular orbital, which is also called sigma star molecular orbital. And in case of pi bonds also, here pi bonding molecular orbital is formed, and pi antibonding or pi star molecular orbital is also formed. And with px and py there is zero overlap, hence no bond is formed, and so no molecular orbital is formed here. So option D is the correct answer. Then here it is told the hybridization of carbon in, in diamond, graphite, and ethine is in the order. So diamond, in diamond, every carbon atom is linked with four other carbon atoms to form a tetrahedral arrangement. Here we have a tetrahedral arrangement or a tetrahedral network is formed in case of diamond. Since every carbon atom is linked with four other carbon atoms. So here every carbon atom is sp3 hybridized. sp3 hybridized. And in graphite, as we know, so in graphite, lots of layers of carbon atoms are formed, and these layers are linked with each other through very weak van der Waal forces. Through weak van der Waal forces. So it means within the plane, each carbon atom is linked with three other carbon atoms. So every carbon atom in graphite is sp2 hybridized. And in case of ethine, in ethine, okay, the two carbon atoms have got a triple bond in between them. So it means that each carbon atom is linked with two other atoms. So every carbon atom is sp hybridized here. So the hybridization in diamond, graphite, and ethine, it will be sp3, sp2, and sp. So it means option B is the correct answer. Then here it is told which of the following structures of a molecule is expected to have three bond pairs and one lone pair of electrons. Which of the following structures of a molecule is expected to have three bond pairs? So three bond pairs are formed and one lone pair is formed. So it is formed in the case of AB3E type molecule. So for example, it can happen in case of NH3, case of ammonia, case of NH3, one lone pair is there on the nitrogen atom and three bond pairs are there. So here the structure is uh, it is triangular pyramidal. The structure is triangular pyramidal or simply pyramidal can also be told. So option D is the correct answer. Then here it is told that which of the following is the correct electron dot structure of N2O molecule. So for N2O molecule, okay, so every nitrogen has got um, 5 valence electrons. So it will be bonded with oxygen. So here, actually n, mm, we can form a negative charge here. One positive charge is formed. It means that it can have 4 electrons in the valence shell here. Here it will have 6 electrons in the valence shell, and here we'll have 6 electrons in the valence shell in case of oxygen. So if we have so from here we can have another resonance structure. We can have another canonical structure for this, where this bond pair goes onto the oxygen atom, and this bond pair goes onto this N plus atom. So it means the structure will be somewhat now like this. Okay. So here actually what will happen, this lone pair will be transferred here. So it will form N triple bond N plus and then O minus. So it means option D is the correct answer. Here it is told the intramolecular hydrogen bond is present in. So in phenol, there will be no hydrogen bond. And in orthonitrophenol, so here we have nitro and here we have phenol. So it is orthonitrophenol. So here actually intramolecular hydrogen bonding can be formed. Here NO2 structure with OH. So here intramolecular hydrogen bond will be formed here. It means the hydrogen bond is formed within the same molecule itself. But in case of paranitrophenol, here the NO2 group is oppositely linked to the OH group. So here we can have intermolecular hydrogen bond, but there will be no intramolecular hydrogen bond. It will be intermolecular hydrogen bond. This is paranitrophenol. And in case of P cresol, for P cresol, the structure is OH with CH3. And since it is para cresol, so the two OH group and CH3 group, they should be oppositely linked. And so here there is no electronegative atom. So here there is no hydrogen bonding here. It means intramolecular hydrogen bond is only in case of orthonitrophenol. So option B is the correct answer. Then here it is told the state of hybrid orbitals of carbon in CO2, CH4 and CO3 2 minus is respectively. In case of CO2, it is linear shape. So here carbon is sp hybridized. In case of CH4, we have tetrahedral shape. So here the carbon is sp3 hybridized. And then in case of CO3 2 minus, here we have CO3 2 minus. So here each carbon atom is linked with three atoms. So three atoms of oxygen. So here carbon is sp2 hybridized. So it means the state of hybrid orbitals for in case of CO2, CH4 and CO3 2 minus ions, it will be sp3 and sp2. sp3 and sp2. So option C is the correct answer. Then here it is told which of the following causes net dipole moment. So in case of SO2, we have the structure is like this. So it means that a net dipole moment should be there here. A net. So here the net dipole moment will not be zero here. And in case of BF3, in case of BF3, so each bromine atom is covalently linked with three fluorine atoms. Each the boron atom is linked with three other fluorine atoms. So it means here the shape will be square planar, and it is a symmetrical shape also. So here the net dipole moment will be zero. The net dipole moment for BF3 will be zero only. And in case of BeCl2, here we have linear shape. So here also the net dipole moment will be equal to zero. Since why it is having a symmetrical shape. And then in case of CO2 also, the net dipole moment, the net dipole moment will be equal to, so in case of CO2, excuse me, the net dipole moment will be zero only. So it means your option A is the correct answer, since why it possesses a net dipole moment. Then here it is told which of the following pairs contains two lone pairs of electrons on the central atom. In case of I3 plus, so here we have I plus, it means that it will have 6 electrons. So 1, 2, 3. Iodine, it will have 1, 2, 3, 4, 5, 6, 7 electrons. So here so these two it will share, or it will give I 7 here one single bond will be formed. Here also another bond will be formed. Here I plus. Here 1, 2, 3, 4, 5, 6. Okay. So it is the structure of I plus. So here it has got two lone pairs on the central atom, and in case of H2 also, it has got two lone pairs on the central atom. In case of NF3, it has got only one lone pair on the central atom. In case of NH3 also, it has got one lone pair on the central atom. And in case of XCF4, it has also got two lone pairs on the central atom, like 1, 2, 3, 4. In case of SO4, H2S also has got two lone pairs on the central atom. In case of SO4, 2 minus also. Minus 1, 2, 3, 4, 5, 6. SO4, 2 minus. So here it has got no lone pairs on the central atom. So here I3 plus and H2O both have got V shape or bent shape, and they both have got two lone pairs on the central atom. And in case of option B, we have H2O and NF3. So here H2O has got two lone pairs, but NF3 has got only one lone pair. And in case of option C, XCF4 has got two lone pairs, but NH3 has got only one lone pair. And in case of option D, H2S has got two lone pairs, but SO4 2 minus has got no lone pairs. So it means option A is the correct answer, which has where I3, since both I3 plus and H2O has got two lone pairs each on the central atom. Then here it is told the formal charge on central oxygen atom in ozone is. So here oxygen atom, it is 1, 2, 3, 4, 5, 6. So here it will form a coordinate bond here. So since here this oxygen atom, uh, it will donate its lone pair to this oxygen atom. So here it means the central oxygen atom will gain +1 formal charge, and this oxygen which is accepting these lone pair of electrons, it will gain -1 formal charge. So it means the formal charge on the central oxygen atom, here it will be equal to +1. Or we can also use the formula for finding formal charge. So formal charge, that is equals to half, it is equal to the total number of valence electrons, minus the total number of non-bonding electrons, or lone pair electrons, minus, which is half of the total number of bonding electrons. So here, therefore, the formal charge on the central oxygen atom, that will be equal to the total number of valence electrons, which is 1, 2, 3, 4, 5, 6. So 6 minus, that is the total number of non-bonding electrons, which is 2, minus half of the total number of bonding electrons, which is 1, 2, 3, 4, 5, 6. 6. So it will be 2, 3 are 6. So it is 6 minus 5, that is equal to plus 1. So option C is the correct answer. Then here it is told that the percentage S character in the hybrid orbitals of nitrogen in NO2 plus, NO3 minus, and NH4 plus are. So now the structures of NO2 plus, NO2 plus, it will be here, it will be like this, N plus O2. Your octet is fulfilled. NO2 plus it is. So here nitrogen atom is the orbitals of nitrogen atom will be sp hybridized, since it has got no lone pairs and it has got two. It is linked with two surrounding atoms. So it is sp2. It is sp hybridization. So here the percentage S character, the percentage S character will be 50%. And then in case of NO3 minus, that will be like this, which is 1, 2, oxygen, 1, 2, 3, 5. Okay. So it is structure is like this. You can draw it like this. Okay. So it is 2, 3, 4, 5, 6, 7. Okay. So it is the structure of NO3 minus. So here nitrogen atom is linked with 1, 2. Okay. Here nitrogen atom is linked with 3 oxygen atoms. So here nitrogen is sp2 hybridized. sp2 hybridized. So here the percentage S character, the percentage S character will be equal to 1 by 3 into 100, or 100 by 3%, or I can say 33.3%. And in case of NH4 plus, here we have 4 hydrogen atoms. 4 hydrogen atoms. So it means here nitrogen is covalently bonded with 4 hydrogen atoms. So here nitrogen in NH4 plus, nitrogen atom is sp3 hybridized. sp3 hybridized. So here also the percentage S character of the hybrid orbitals of nitrogen, that will be equal to 1 by 4 into 100. So that is 25%. So it is 50%, 33.3%, and 25%. So option B is the correct answer. Yep. Okay, so here it's told that the bond angle in pH4 plus is more than that of pH3. So for pH3, the structure is like this. Phosphorus has got one lone pair on it. So the for pH3, the structure is triangular pyramidal, has got pyramidal structure. And for pH4 plus, it has got, the structure will be like this. it will give this lone pair to H plus ion. So it will be pH4 plus ion. So here the structure pH4 plus structure is tetrahedral. And so here the bond angle, here, that will be 109 degree 28 minutes. Mm. But here, since lone pair is present, so here we will have lone pair bond pair repulsion. There will be lone pair bond pair repulsion here, which will result in the decrease of the bond angle. So here the bond angle will be less than 109 degree 28 minutes. So since here we have no lone pair bond pair repulsion, so hence the bond angle is higher. So the actual reason is that lone pair bond pair repulsion exists in pH3. So it means option D is the correct answer. Then here it is told which of the following is an incorrect statement. Hydrogen bonding is stronger than dispersion force. Sigma bonds are stronger than pi bonds. Ionic bonding is non-directional. Sigma electrons are referred to as mobile electrons. So option D is the incorrect statement, since why sigma electrons are the bonding electrons. These are the bonding electrons. So they are they are localized electrons. Localized means they are fixed. They are localized electrons. It means they do not move in the structure. Means they do not move. So hence option D is the correct answer, since why it is the incorrect statement. Then here it is told the correct order of boiling point in the following compounds is. So 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 we have in H2O and in HF and in NH3, in all of them we have we have hydrogen bonding. We have intermolecular hydrogen bonding in all these three. We have intermolecular hydrogen bonding in all these three. So, and in case of H2O, each oxygen atom is linked with two is linked with two hydrogen atoms, and each hydrogen atom is linked with one oxygen atom. So here uh, the number of hydrogen bonds per molecule is the highest. So the hydrogen bonding is more stronger in H2O than in HF. In HF also hydrogen bonding is present, but in HF only one hydrogen bond per molecule is present. Or we can say actually, okay. So for each molecule of HF, this hydrogen is linked, is uh, hydrogen bonding is there with the fluorine atom of the other molecule of HF, and each fluorine atom is also hydrogen bonded with another hydrogen. Okay. So hence the for each molecule of HF, on an average, only one hydrogen bond is formed, and in H2O, we can say two hydrogen bonds are formed per molecule of H2O. So for H2O, the number of intermolecular hydrogen bond is higher. So the boiling point of H2O will be also higher than that of HF. And in case of NH3, the electronegativity of nitrogen is lesser than fluorine. So here also the hydrogen bond which is formed is not that strong, is not very strong. So the boiling point of ammonia NH3 is lesser than that of HF. So option B is the correct answer. Then it is told that in oxygen and carbon molecule, the bonding is. So if we write the molecular electronic configuration of O2 in terms of the molecular orbital theory, then we know that O2 has got 16 electrons. So if you write the molecular electronic configuration, then it will be sigma 1s2, sigma 2s2, no, sigma star 1s2, then sigma 2s2, sigma star 2s2, then sigma 2pz2, then pi 2p x2 equals to pi 2p y2, and then pi star 2p x1 equals to pi star 2p y1. Now, therefore, the bond order of oxygen that will be equal to half of the number of bonding electrons, which is 1, 2, 3, 4, 5, 5 to the 10, minus the number of anti-bonding electrons, which is 1, 2, 3, so it is 6. So it is 4 by 2, that is equal to 2. And so we can cancel out this sigma 1s2 with sigma star 1s2, and sigma 2s2 will cancel with sigma star 2s2. So here these two bonds which are formed. So one of them is the sigma bond and one of them is the pi bond. So here one sigma bond and one pi bond is formed in oxygen molecule. But in case of C2 molecule, here in C2 we have got 12 electrons. So if we write the molecular electronic configuration of this, then it will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, then sigma 2pz2, then here, no, here carbon is before nitrogen. So first we have to fill pi 2px and pi 2py, then we will fill sigma 2pz. So first we will write pi 2px 2 equals to pi 2py2. So here we will have 1, 2, 3, 4, 5, 6 here. Is it? 12. So here the bond order of C2 molecule, that will be half of the number of bonding electrons, which is 1, 2, 3, 4, 4 to the 8, minus the number of anti-bonding electrons, which is 4. So it will be also 2. So in these two bonds which are formed, as you can see, sigma 1s2 and sigma star 1s2 will cancel. Sigma 2s2 and sigma star 2s2 will cancel. So here both these bonds which are formed, these both are pi bonds. Both are pi bonds here. So it means that in case of O2, one sigma bond and one pi bond is formed, and in case of C2 molecule, no sigma bonds or zero sigma bonds and two pi bonds are formed. So it means option A is the correct answer. Then here it is told which of the following statement is incorrect. The bond length of O2. Now, if we write the molecular electronic configuration of O2 2 minus, it has got 18 electrons. So that will be, so here we shall start from sigma 1s2, sigma star 1s2, and then we shall go till pi 2p. Here also we will have sigma 2p z2, then pi 2p x2 equal to pi 2p. Okay, let's write the full electronic configuration only. So then sigma 2s2, sigma star 2s2, then sigma 2p z2, then pi 2p x2 equals to pi 2p y2, then pi 2p pi star 2p x2 equals to pi star 2p y2. So here the bond order of O2 to minus ion, so that will be half of the number of bonding electrons, which is 1 2 3 4 5, so 10, minus the number of anti-bonding electrons, which is 1 2 3 4 4 to the 8, so this will be 1, and this 1 is the sigma bond. And in case of O2, which has got 16 electrons, it will be same configuration only, but here when we start from sigma 1s2, at the end we will have pi star 2px1 equals to pi star 2py1. So here the bond order of oxygen, that will be equal to half of 10 minus 6, that will give you 2, and in these two we have one sigma bond and one pi bond. So it means, as we know that the, and in case of O2 plus, okay, now for O2 plus it has got 15 electrons, so here we will go from sigma 1s2 to pi star 2px1. Now here the bond order of O2 plus, that will be equal to half of 10 minus 5, so it will give you 2.5. Then the bond order of O2 2 plus, the, now for O2 2 plus it will have 14 electrons, so here we will go from sigma 1s2 sigma star 1s2, then sigma 2s2 sigma star 2s2, then sigma 2pz2, then pi, sorry, it will be pi 2px2 equals to pi 2py2. So it will be 1 2 3 4 5, 1 2 3 4 5 6 7. Okay, yeah, it will be till here. So in case of O2 2 plus, the bond order of O2 2 plus, that will be equal to half of the number of bonding electrons, which is 1 2 3 4 5 10, minus the number of antibonding electrons, which is 4, so it is 3. So it means the bond order, here it is asked which statement is incorrect. Now, as we know that when bond order increases, the bond length decreases. Now it is told the bond length of O2 is less than the bond length of O2 2 minus. That will be true only, since why the bond order of O2, that is 2, and the bond order of O2 2 minus is 1. So it means the bond length of O2 will be obviously less than the bond length of O2 2 minus. So option A has the correct statement. And in option B, it is told bond order of O2 is more than the bond order of O2 2 minus, which is also true only. Then in option C, it is told the bond length of O2 is more than the bond length of O2 2 plus. Now the bond order of O2 2 plus is 3. So it means which is more than the bond order of O2. So it means therefore the bond order of O2, no, sorry, the bond length of O2 2 plus should be less than the bond length of O2. So it means the bond length of O2 is obviously more than the bond length of O2 2 plus. Yeah, so C The statement in option C is also a correct statement. But in option D, it is told the bond order of O2 plus, which is 2.5, and which is less than the bond order of O22 minus, which is wrong. Since why the bond order of O22 minus is 1, which is obviously less than the bond order of O2 plus, which is 2.5. So it means option D is the correct answer, since it is the incorrect statement. Then here it is told dimerization of solute molecules in low dielectric constant solvents is due to. So dimerization, it means that two molecules uh, are are linked. When they are linked with hydrogen bond, when two molecules are linked with a hydrogen bond, then one dimer is formed, which is called the process of dimerization. So it happens due to hydrogen bonding. So option C is the correct answer. Then here it is told the number of antibonding electron pairs, in O22 minus molecular ion on the basis of molecular orbital theory is. Now here it is told something wrong, that the atomic number of O is 18, which is wrong. It will be 8. The atomic number of oxygen is 8. Okay. So therefore, the molecular electronic configuration of O22 minus ion, according to the molecular orbital theory, that will be equal to, according to the, so it will have 18 electrons. So that will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, then sigma 2pz2, then pi 2px2 equals to pi 2py2, then pi star 2px2 equals to pi star 2py2. So here 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So it has 18 electrons. So it is the required molecular electronic configuration according to the molecular orbital theory. So now here it is told to find the number of antibonding electron pairs. So the number of antibonding electron pairs. Okay. Number of antibonding. Okay. So here it is the number of antibonding electron pairs to find. So that will be equal to 1, 2, 3, 4. 4 antibonding electron pairs is there. So option 3 is the correct answer. And here it is told for a stable molecule, the value of bond order must be positive. So if the bond order is positive, it means if bond order is greater than 0, which also means that if the number of bonding electrons, is more than the number of antibonding electrons, then only a stable molecule is formed. And only a stable molecule will be formed. So option 2 is the correct answer. Then here it is told during the formation of a chemical bond, the energy decreases. Since why? When two hydrogen atoms, for example, when they will come close, so then we have a a graph of potential energy with their internuclear separation x. So the graph is somewhat like this. So here, when the minimum potential energy is formed, then we have the equilibrium internuclear separation, and this equilibrium internuclear separation is only called as the bond length of the uh, molecule. So it means that when a bond, a chemical bond is formed, then the energy will decrease. So option 2 is the correct answer. Then here it is told, in acetylene molecule between the carbon atoms. So in acetylene means C2H2. C2H2 is called acetylene molecule. So here, uh, here a carbon-carbon triple bond is formed with two hydrogen atoms. So in between the carbon atoms, here we have one sigma bond and two pi bonds. Two pi bonds. One sigma and two pi bonds. So option 3 is the correct answer. Then here it is told, which of the following is diamagnetic. So the following is diamagnetic. One is H2 plus. H2 plus is mm, so H2 plus has got one electron. So its molecular electronic configuration according to the molecular orbital theory, its molecular electronic configuration is sigma 1s1. So it is paramagnetic since it has got one half filled molecular orbital. So it is paramagnetic. So if all molecular orbitals are fully filled and there are no half filled molecular orbitals, then only the molecule will be diamagnetic. So here, in case of Li2 molecule will have 6 electrons. So its molecular electronic configuration will be sigma 1s2, sigma star 1s2, and sigma 2s2. So here all molecular orbitals are fully filled, so it is a diamagnetic species. It is a diamagnetic species. And in case of O2 also, as we know, it has got 16 electrons, and here at the end it starts from sigma 1s2, and at the end we have pi star 2px equals to pi 1 equals to pi star 2py1. So here we have two half filled molecular orbitals, so it is paramagnetic. It is paramagnetic. And then in case of He2 plus also, it has got 3 electrons, so its molecular electronic configuration will be sigma 1s2, sigma star 1s1. So here also we have one half filled molecular orbital, so this is also paramagnetic. So it means option 3 is the correct answer, which is Li2, since only Li2 is diamagnetic. Then here it is told, which of the following has the highest bond order. Okay, here, which has got highest bond order. So here, as we know that for N2, we have 14 electrons, and its molecular electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma 2, sigma star 2s2, then pi 2p x2 equals to pi 2p y2. Okay. Then we have sigma 2p z2. So here we have, yeah. So therefore, the bond order for N2, that will be equal to half of the number of bonding electrons, which is 1, 2, 3, 4, 5, is 10 minus ten. So here it will be 10 minus 1, 2, so this is 4. So that will be 6 by 2, that is 3. Then for O2, as we know, it has got 16 electrons and it will start from sigma 1s2 and it will end at pi star 2px equals to pi star 2p y 1. So here the bond order of O2 that we know, that will be equal to half of 10 minus 6, that will be equal to 2. Then for He2 also, it has got 4 electrons, so it will be sigma 1s2, sigma star 1s2. So therefore, the bond order will be half into 2 minus 2, that is equal to 0. And for H2 also, it has got 2 electrons, so its molecular electronic configuration will be sigma 1s2. So the bond order for H2 will be equal to half of 2 minus 0, that is equal to 1. So the highest bond order is for N2 only. So option 1 is the correct answer. Then here it is told that hydrogen bond is strongest in. So the hydrogen bond will be strongest in HF. In since fluorine is the most electronegative element. Fluorine is the most electronegative element. Most electronegative element. So here the partial negative charge on fluorine atom and the partial positive charge on hydrogen atom which are formed, that is the highest. So here the hydrogen bond will be strongest. Here the hydrogen bond is strongest. So option 3 is the correct answer. Then here it is told which of the following represents the Lewis structure of N2 molecule. So as we know, nitrogen will have 1 electron pair and 3 electrons will be shared. So it means option 1 is the correct answer. It has got 3 bonds and so the octet will be completed. So since 3 to just 6 plus 2, 8. Octet is fulfilled. Then here it is told an atom of an element A has 3 electrons in its outermost orbit. So it means that it can have A 3 plus state. And B has 6 electrons in its outermost orbit. So it can form A B2 minus state. It means since it has got 6 electrons, so it is in the oxygen family. Oxygen family, it means it is a kind of chalcogen. It means its valency will be -2. And for A, the element A, it is a 3. It has got 3 electrons in its outermost orbit. It means that it is in group number 13 element, or I can say it is in the boron family. It is in boron family. So its valency will be +3, or its oxidation state will be +3. So it will form A2B3. A2B3 will be the required formula of the compound which will be formed in between A and B. A2B3 is the required formula of the compound which will be formed between A and B. So option 2 is the correct answer. Then here it is told in acetylene molecule the 2 carbon atoms are linked by the two carbon atoms are linked by free. So here we have one sigma bond and one pi bond. One pi, no, two pi bonds. So option 3 is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam on the chapter chemical bonding and molecular structure. Still any doubts if you have, please write that in the comments section. We shall obviously clarify them in the subsequent few videos, and also in yeah, and also please install our Sapience education application, where we shall upload some important homework questions based on the previous year KCET exam on every chapter of chemistry, which shall be obviously helpful for your exam. So thank you everyone. Bye.